Hello, Advanced Geometry students. It's Mr. Donaldson coming to you from the home office. And here we are, first day of geometry notes. Pretty exciting. So today we're going to start off with the three most basic, fundamental building blocks of geometry: point, line, and plane. As we discussed yesterday, these are the first three terms in our geometry language, so we technically cannot define them. However, we can use these three undefined terms to define all other terms in geometry. All right, these are our starting words. We use these to define everything else. Because these are the first words in geometric language, we can't define them. We don't have other words to use to define them. So we'll just kind of describe them and understand what they are. So first is a point. A point represents a location in space. You look around you right now in your room, there's an infinite number of points. It's floating around everywhere. So many different locations. The way we kind of represent a point is we use a dot, as you'll see over here. And a point has no size or dimension. We name a point by using a single capital letter. So if I was going to name this point here, I would name it H. And you would probably be tempted in the beginning of this class, if I said to name a point, you'd be like, oh, point H. But you guys, this is unnecessary. And the reason it's unnecessary is because in geometry, capital letter implies a point. So if you wrote the word point first, I would read it as point H, which seems kind of funny. So if I ask you to name a point, all you need is one single capital letter, and you are good to go, and you are done. There you go. I read this as point H. Next is a line. So a line is an infinite number of points, and it extends infinitely in opposite directions, has no width, and has one dimension. That one dimension is that length when you start extending those points. So I made a little sketch to try to show you how this connects to a point. So here I have my point B, and if you imagine me just adding an infinite number of points, I'm going to put another point, then another point, then another point, an infinite number of points. And if I could also do it back in this opposite direction, I would end up with a line. All right, so one point, and then you take an infinite number of them and you line them up going back and forth in opposite directions, you get a line. And of course, I can't continuously draw infinitely on my computer screen, so we'll just kind of assume that this continues to go on forever. All right, now the way you name a line is with two letters. So all you need is, or 2 points I should say, excuse me. All you need is 2 points anywhere on that line. So if I look at this line, I'm like, all right, well, I can name it AC, I can name it BC, I can name it CB, I can name it CA. I got a lot of different choices, but all you got to do, it doesn't matter which one you put, as long as you choose any 2 points on that line. So maybe you want to name it line AC. Maybe you want to name it line BA. Doesn't matter. Now another way you can name a line is you can name a line by using a lowercase cursive letter, which sometimes will be next to lines but not always. And if it is there, it's nice because it's just a little shortcut. So this means, hey, that's just line M. And your textbook with this notation is not very consistent. Sometimes they just put a little lowercase letter and you should know that represents a line. There'll be a drawing next to it. And sometimes they actually write the word line in front of it. In this case, you just make sure you understand in the context of what they're asking you to do, but a little lowercase cursive letter represents a line. So you can call this line M as well. All right, next is a plane. Now a plane is kind of an extension of a line. In this case, a plane is like a big flat surface that extends forever in 2 directions without end. It contains an infinite number of points and has 2-dimensional, and it has no thickness. And if I go back to that sketch I was showing you earlier, so I started with a point, and I extended it forever in this direction, got a line. And now if you could take that line and you could stretch it out forever in this direction, you end up with this nice flat surface, and that is your plane. No thickness, but it has 2 dimensions, its width and its length. All right. Now the way you name a plane is you name a plane using 3 non-collinear points. Now I know we haven't technically defined this yet, and we will in just a second, but non-collinear just means 3 points that are not in a straight line. And I can show you very quickly why they can't be in a straight line. If you look at this sketch that I have made, you can see there are two planes there. There's that red vertical plane and there's that green horizontal plane. Now, if I said, hey, name the red plane, and you told me, oh, it's plane ADB, well, you'll notice that A, D, and B not only lie in the red plane, but they also lie in the green plane. So if 3 points are in a straight line, they lie in more than one plane. So what you're going to do rather is pick 3 points that aren't all on the same line. So you would name this red plane maybe ADE, and you'll know for sure those 3 points are only on the red plane. They're not all 3 on the green one. So when you're naming a plane, the 3 points can't be in a straight line. All right, so if I want to name this plane, I could say DEF. And just like with point, how you don't have to write the word point, when you're naming a plane, you don't have to write the word plane either. And the reason for that is in geometry, if I see 3 capital letters next to each other like that with no commas or other notation, I know for sure you're talking about a plane. You could not name this plane EFG because look, there's another plane down here that contains EF and G. You have to use 3 points that are not in a straight line. So another option for naming this plane maybe would be, I don't know, IHJ. And there's another way you can name a plane as well. Just kind of like how sometimes a line has this little cursive letter as a shortcut. Sometimes planes up in the corner of the little drawing of the plane will have a little, or a capital rather, cursive letter, and you can name the plane using that. So in this case, I can name this plane W. And again, the book is a little inconsistent. And typically it uses that word plane in front of the W. And it doesn't really matter because you have a picture, you'll be able to tell what they're talking about. All right. So now that we understand the 3 undefined terms of geometry, we can use these terms to define others. So in addition, this is really important. So in addition for me to introduce definitions to your notes, I'm also going to keep a running glossary on our Schoology page so that you could always go back, because the book's glossary really stinks. It doesn't do a good job of giving you good definitions. So we'll keep a running glossary on Schoology so you can go back and get definitions if you forget a definition of a word. So collinear, same, linear, line simply means on the same line. You probably know this prefix co, like a co-ed dorm has boys and girls. Co-workers, people that work at the same place. So co means same, linear means line, so collinear, on the same line. So I could draw a diagram, and I know if I put some points on this line, because they're all on the same line, points A, B, and C would be collinear. You guys will notice right here I have a little note that says any 2 points are always collinear. And the reason for that is because no matter where I drew 2 points, there's always a line that goes right through those 2. And I know my handwriting's terrible on this stylus, so sorry about that. But anywhere you put 2 points, like if you hold up a finger right now, at the tip of your finger there's a point, and I got a point at the tip of my finger in my house, there is a straight line that connects those 2 points. All right? So any 2 points are always collinear. Now non-collinear, of course, not on the same lines. If I wanted a diagram of that, I'll draw a line best I can here with this stylus. I'm going to put 2 points on that line, maybe X and Y. And then I'll put point Z not on that line. These 3 points are non-collinear because they are not all 3 on the same line. So you would say, hey, points X, Y, and Z are non-collinear. Coplanar. Coplanar is on the same plane. So just draw myself a little plane here. Best I can. Again, it's really bad, I know. Let's throw some points on it. We got A, B, C, D. All 4 of those points, A, B, C, and D, they're all on the same plane. So I know for sure they are coplanar. And there's a little note here. It says any 3 points are always coplanar. And that's because if you think about, well, let's go back and look at this sketch maybe. All right. So when I made this green plane, I started off by putting it through these 2 points, A and B. And you can imagine that that green plane wobbled back and forth, up and down, until I had this 3rd point, C. As soon as I defined C and said, hey, I want that plane to go right through C, then it was done. There's that flat surface, and there's where it existed. So if you have 3 points, 3 points will always be coplanar, but sometimes a fourth point can be, like in this case, if I have A, B, and C, well then this point, what is this point? G is also in that green plane, so those 4 points would be coplanar, but you know, F is not in the same plane as those other points, so you could have some non-coplanar points in this situation as well. So non-coplanar just means not in the same plane. So if you wanted to draw a little sketch of that, you'd simply draw a plane. You put some point down here beneath it that's not on it, maybe call it A, and then a couple points on the plane here. So in this case, B, C, D, and A are non-coplanar because they're not all on the same plane. All right, so just a couple examples. You may just want to pause it right here and see if you can kind of answer these questions yourself. Come back and check. All right, hopefully you took a moment and paused it and did that. If not, here we go. Let's talk about them. What's another name for line BG? All right, well, line BG, here's line BG. Now, I know there are not arrows on the end of this, but remember, a plane goes on forever, so I know any line on that plane will also go on forever. So this is definitely line BG. If I want another name for that, I just need any 2 points on it. So how about line BE or line EG? The little line on top. What is another name for plane P? Well, here's plane P, that big gray one. Well, to name a plane, you need 3 non-collinear points. So I'm just going to pick 3 points that are not in a straight line that are on this gray plane. How about C, D, and E? I don't have to write the word plane. If I see 3 capital letters next to each other, I know in geometry we're talking about a plane. What's another name for line T? Well, here's line T. I just need any 2 points on it. So how about line MK? You could have said line LM. You could have said line ML. You get a lot of choices. You just need any 2 points on it with a line over the top. Name 3 collinear points. So collinear is on the same line. There's a lot of choices here. So maybe I'll go with C, F, and J. Now be very careful though when you're naming 3 points. C, F, and J. Make sure you use commas and list them, because if you just put CFJ, I would think you were talking about a plane, but you're really listing points for me. Next question, are points A, B, E, and H coplanar? Well, yes, they are, because A, B, E, and H are all on that blue plane. So yes. Are points A, B, and C coplanar? Well, the answer to this is also yes. First of all, I told you in the notes that any 3 points are always coplanar. But second of all, if you can imagine, I could draw a plane that goes from here and goes up there through C. And I know it's hard, like I said, for me to draw with this stylus, but there is a flat surface that exists that would go through A, B, and C. It's just not drawn. Just because it's not drawn doesn't mean it doesn't exist. All right, name 3 non-collinear points. So I just want any 3 points that are not in a straight line. So maybe I'm going to start out by picking 2 that are in a straight line, A and B. And then I'm just going to pick my 3rd point that is definitely not on that line, AB. So how about M? So A, B, and M are non-collinear. And then the last question is, how many points are in this diagram? And before you start painstakingly counting 1, 2, 3, 4, 5, 6, remember, if it's not drawn, doesn't mean it doesn't exist. There is an infinite number of points in this diagram because there are points all over these planes and all over these lines. There's an infinite number of points in that diagram. All right, guys, I know that's a lot. In the beginning of geometry, this kind of understanding of notation is really important, but it can be a little tedious. So thanks for hanging in there, and good luck with your assignment. Let me know if you need any help.